Hi, and welcome to Unit 10, Day 3. Today we're going to compare areas of similar figures. So we need to do a little bit of recalling when we're talking about area. We know that we have to work with a scale factor, and a scale factor is the simplified ratios of corresponding sides of two similar figures. Okay, and then we also know that you have perimeters of similar figures, and if two polygons are similar, the ratios of the perimeters is equal to the scale factor. So that's important to remember, is that the ratio of the perimeters is equal to the scale factor between them. Okay, so that's going to be something important to remember as we go on. If we're given a square whose sides are 2 inches and a second square whose sides are 3 times the first square, how many times bigger will the area of the new square be? So we're going to make the new square 3 times bigger than the first square. So it's instinctual that the new area would be 3 times bigger. But let's just take a look at this. We have an original square whose sides are 2 inches. So 2 inches by 2 inches by 2 inches. Just a little square here, 2 by 2 by 2 by 2. And we're going to multiply it so that it's 3 times bigger. Okay, so I'm going to multiply it so that it's 3 times bigger. So if I make it 3 times bigger, pretend that's a square. It's a little wonky. But instead of 2, I'm going to multiply that by 3. So 2 times 3, this is now going to be 6 by 6 by 6 by 6 all the way around. Okay, so how many times bigger will the area be? I know that the sides are 3 times bigger. 2 times 3 gives me 6. But let's look at the two areas. If I want to find the area of this smaller one, area is going to be, if it's a square, it's going to be base times height, so 2 times 2, which is 4. Okay, when I look at the area of the bigger, the new square, my area is, again, it's a square, so it's base times height, 6 times 6, which is this time 36. So even though we're 3 times bigger, if I look at my areas and I compare them, it's 2 times 3 gives me my 6, but 4 times 3 does not give me 36. 4 times what gives me 36? Well, let's see. If I do 36 divided by 4, I'm going to have to do 4 9 times to get to that 36. So how many times bigger will the area of the new square be? The new square will be 9 times bigger than the old square. Okay, your new square will be 9 times bigger than the old square. And that's because the areas of similar figures, when we look at them, if two polygons are similar, the ratio of their areas is equal to the square of the scale factors. Okay, so when I multiply everything by 3, my scale factor becomes 3 to 1 because this one is 3 times bigger. So 3 to 1, and then I square the 3 times 3, and I get 9. Okay, so what you're going to see that I'm going to do on each of these whenever I'm doing a problem and I'm working with ratios or similar figure, anytime I see the word similar, I'm going to create what I call a SPA table, where we've got our surface area that is some sort of, or scale factor, S for scale factor, that's some sort of simplified ratio of, let's say, A to B. Okay, our P stands for perimeter, and our perimeters have a ratio that's equal to the scale factor. So if my scale factor is A to B, the ratio of the perimeters will also be A to B. But then I've got the ratio of the areas. My ratio of my areas, think area, you think units squared, right? So it's going to be the square of the scale factor. So it's going to be A squared over B squared. And so you'll see each time, anytime I see that word similar in a problem from here to the end of the school year, really even further than that, anytime you see similar and you're working with it, you can always create what I call a SPA table. Okay, so let's look at some examples. Number 1 says for each pair of similar figures, find the area of the shaded figure, round to the nearest tenth. So I'm going to first do exactly what I said I was going to do. I'm going to create a SPA table. Okay. Now, I know I told you that S stands for scale factor, P stands for perimeter, and A stands for area, and I'm immediately going to tell you that I use them differently. When I see S, I do think scale factor, but I also think the scale factor is found by looking at the ratio of the sides. Okay, so when I look at this problem here, I can think of comparing the sides under S. Now, the first thing I want to do when I'm looking at pictures is I need to make sure I stay consistent as I set up all these ratios. So if you remember way back in Unit 5, when we were doing similar figures, I said, let's put an up arrow in one figure and a down arrow in the other. So when I'm creating my ratios, I will always remember that everything from my up arrow triangle will go in numerators and everything from my down arrow triangle will go in denominators. Okay, so the first thing I'm going to do is I'm going to compare the sides 5 and its matching side 15. And since I put my up arrow on the one with the 5, that's going to go on top. And then in the bottom is going to be the one from the down arrow. And then I'm going to go ahead and reduce. If you have a hard time reducing, if reducing just isn't your thing, this is a more simple one to reduce because we can see that 5 goes into both. But I want to show you in the calculator, if you do 5 divided by 15, you can hit right here under the green alpha, you have this math button, and number 1 says make it a fraction. So you just hit number 1, or you can just hit enter because it's already the one is highlighted. And then it tells you I'm going to take this and I'm going to turn it into a fraction. When I hit enter, it tells me that reduces to 1/3. And I know y'all probably could have done that without the calculator, but I wanted you to see how that works. Okay, so I know that the ratio of the perimeters is also going to be 1/3. And the ratio of the areas is going to be the square of the scale factor. So it's going to be 1 squared over 3 squared. 1 times 1 is 1, and 3 times 3 is 9. Okay, so now if I look, I know I'm trying to find the area of this shaded figure. Okay, so now I'm going to compare my areas. My area from my up triangle is 12. The area from my down triangle, I don't know, I'm going to put an X. I don't know what that is. That should reduce to the ratio of the areas that we found. It should reduce to 1/9. This, all I have to do then is cross multiply. So I'm going to do X times 1 and 12 times 9. X times 1, that's pretty simple. That's just X equals, and then 12 times 9 is 108. Okay, so my area for the second triangle, my shaded triangle, is 108, and my units, meters, meters, meters squared, since it's the area, we know it's meters squared. Okay, let's do another one just like this. All right, so example number 2, the first thing I'm going to do is I'm going to make myself a SPA table. So just like the last time, SPA. And remember I said the S stands for scale factor, but sometimes I think of it as sides. And the P stands for perimeter, and the A stands for area. And then I said, remember, as soon as I said this is scale factor, just kidding, I'm going to think of it as sides. I'm going to talk about the same thing with the P. I'm going to say, just kidding, I'm going to think of this also, in addition to perimeter, I'm going to think it as parts. Okay, and so what I mean by that, when I say parts, I mean, for example, in these two figures, I have an altitude and I have an altitude. So those are parts, like pieces of these shapes. So that I can put here under P. And again, these two, my scale factor and my parts or my perimeters, should be the same. And then I square it to get the areas. Okay. First thing I need to do though is figure out which one I'm going to put in the numerator and which one I'm going to put in the denominator. And it doesn't matter. I usually go the one on the left, I put on top, and the one on the right, I put on the bottom, but you can do it however you want to do it as long as you stay consistent. Okay. So I'm going to look at my ratio of my parts, 3 and 6. The 3 was from the up triangle or from the up parallelogram looking figure, and the 6 is from the down quadrilateral, so up and down. And then I'm going to reduce that, and we should be able to reduce that without the calculator, but just in case you want to see how to do that again, 3 divided by 6, I'm going to hit the math button, choose enter because fraction's already chosen, and I can see it reduces to 1/2. I know the scale factor then is 1 to 2. And then to find the ratio of my areas, I'm going to square the scale factor. So 1 squared over 2 squared is going to give me 1 times 1 and 2 times 2. So the ratio of my areas is 1 to 4. Okay, my up area is 20. My down area is, I don't know. That's what I'm trying to find. I'm going to call that x. The ratio of these areas should reduce to the ratio of the areas, 1 to 4. And this, I'm ready to cross multiply. X times 1 and 4 times 20. So x times 1 and 4 times 20. X times 1 is just x, and 4 times 20 is, I believe, 80, but it's nice to just check and make sure 4 times 20 is 80. So my area here is going to be 80, and my units are inches, and it's area squared. Okay. All right, so we'll continue practicing this in the next video. We're going to do one more like this, and then we're going to go on and see if we can use this formula, this table, if we can use it kind of working backwards. So come on back and see how another way we can use our SPA table. Thanks so much for watching.